Hello and welcome to Chapter 5, Section 6. This is on direct variation. Direct variation is a linear relationship that can be written y equals kx, and that's all it can have. And k is a non-zero constant. K can't be zero. And they call k the constant of variation. So when you're being asked questions, I need you to remember that title. And they'll ask you to identify a direct variation, which really means rewrite the equation to match the format y equals kx. So they've given you 3 different samples, and they'd really just like you to be able to rewrite this so it's y equals kx and then be able to tell us what k is. Well, the first one is stupid. It's already written in y equals kx form where k equals 4, and that's it. This one is written in standard form, and you're going to have to rewrite it so that only y is on this side of the equation to tell me if you can get it into y equals kx format. So we're going to add 3x to both sides, and we end up with 5y equals 3x, and we divide each side by 5, and we get y equals 3/5 x. And yes, this is a direct variation where k equals 3/5. This one, I want y by itself, so I'm going to subtract 2x from both sides, and here I have y equals negative 2x plus 10. I can't get just this number. I've got extra numbers here, so no, this is not a direct variation. Try these yourself. There are 3 check it out problems on page 336, number 1. Go through those and see if you can tell me whether they are or are not direct variations, and if they are, what k equals. Pause here, come back when you're done. Number 1 has 3y on one side, so all I needed to do was divide both sides of the equation by 3 to get y equals. And I have 4/3 x plus 1/3, and it's this extra plus 1/3 that means no, this is not a direct variation. B is a direct variation. If I divide each side by the negative 4 that's in front of my y, I get y equals negative 3/4 x, so yes, k equals negative 3/4, and then C is also a direct variation. Subtracted 3x from both sides to get y equals negative 3x, and k equals negative 3. The next thing it's going to ask us to do is to solve for the direct variation. Well, we're going to start with y equals kx, but what is the direct variation? What does k equal? Well, if I divide both sides by x, I can tell you that k equals y divided by x. So that's all they want. In a direct variation, if you can do y divided by x, you can solve for k. If you have a whole bunch of points, you can set them up in y divided by x, and if they all equal the same k, then you know that you've got a direct variation equation without having to solve for the equation. You can just plug a bunch of points in. If all of the y divided by x relationships are the same, if they're all the same k, then it is a direct variation. So for example here, we're given this chart where they've given us what the x's and y's equal, and if you do all of them, y over x, y over x, y over x, and you solve for them, this is 6, and this is 6, and this is 6, so this is a direct variation. With this one, this is negative 1, and this is 0, and this is 1/2, so no, this is not a direct variation. Now, there's another way to do this. You can actually, if you're looking at this, if you don't want to do all that math, because different brains work different ways and different people have different preferences. If you write the equation for this like you were making an XY chart, how do I get from x to y? Well, this is times 6 times 6 times 6. And so if you can do x times 6, then that's your equation. Y equals x times 6, 6x, and where 6 is your constant. Here you can just look at these and try and find that same pattern. How do I get from x to y? Here it's times -1, here it's times 0, and here it's times 1/2. So you don't have anything you can do to x to make a y. If you don't have this change constant, then you can't write that equation, so it's not. So it really depends just on what you're more comfortable with, what part of solving these equations you're more comfortable with. So try it with the check it outs on page 337, number 2, just to see which version you're more comfortable with, the one that gets you the correct answers, the ones that's quickest for your brain. Pause the video here, try number 2, and come back when you're done. So for number 2A, the ratios that we make, or the changes from x to y that we see, are not the same. So this is not a direct variation. With B, the ratios are the same, and or what you do to get from x to y is all times 4. So yes, this is a direct variation. Excuse me, times -4. With C, the ratios are not the same, and here I couldn't find a good way to get from this one to that one, but I did easily get these two, and I see that these two don't work. I don't have to worry about that one. I already know it doesn't work. The next thing it asks us to do is write and solve direct variations. So the question sounds like this. The value of y varies directly, which means it falls into the y equals kx category. And y equals 6 when x equals 12. Find y when x equals 27. There are two ways you can do this. The first way you can do it is write the equation. I know that y varies directly with x, so it's going to be a y equals kx, and y equals 6 when x equals 12. Well, based on this, I can solve for k, and I know that k equals 1/2. Stick that back in the equation, and it says find y when x equals 27. If x equals 27 and k equals 1/2, solve for y. And now all I'm doing is finding half of 27, and y equals 13.5 or 13.5. Now, if you love solving equations, great, do that. If you prefer to use a proportion, you can do that as well, remembering that k is the same as y over x. So we're going to look at a proportion of, here's the proportion they're giving us. They're giving us this one. Y is 6, x is 12. And then find y when x is 27. We're going to use cross products to find our answer. So we know that 6 times 27 equals y times 12. And 6 times 27, 162, equals y times 12. And we divide by 12, and y equals 13.5. So you can solve these whichever way you're more comfortable. The next thing we have are word problems. How do we graph direct variations? So we've got a 3-toed sloth who's an extremely slow animal. On the ground, it travels at a speed of about 6 feet per minute. That's our constant. Write a direct variation equation for the distance y a sloth will travel in x minutes. So we know that distance is y, minutes is x. Our constant is 6 feet per minute. And so our equation y equals kx means that we have to graph for each minute for a few minutes so that we can get our complete graph, so we can figure out how far he's going. So our little chart is going to look like this. And if we do 0, 1, 2, 3, and 0 is 0, and 1 is 6, and 2 is 12, and 3 is 18. So when we graph this, and of course we don't have any negatives because you can't go negative 2 minutes, 0, 0, and 1 is 6, and 2 is 12, and 3 is 18, and our graph is going to look like this. Direct variation word problems are really pretty straightforward. Give them a shot. Give number 4 on page 338 a shot. Pause the video here, come back when you're done. So you've got 2 different check it outs to do on page 338, numbers 3 and 4. Pause the video here and come back when you're done. All right, check it out number 3. The value of y varies directly with x, and y equals 4.5 when x equals 0.5. So I'm going to start by solving the equation, plugging y and x in. I'm going to divide each side by 0.5 so I can get k. And then the question is, find y when x equals 10. Find y when k is 9 and x is 10, y is 90. Or we can solve it the proportion way. Y is 4.5 and x is 0.5. What is y when x equals 10? So 4.5 times 10 equals 0.5 times y. And 4.5 times 10 is 45, and I'm going to divide each side by 0.5, and y equals 90. So I get the same answer both ways. Really, it depends on what you're more comfortable with. And then the word problem that they have, the perimeter of a square varies directly with its side length x. Well, and I know that the perimeter of a square, perimeter is going to be 4 times the sides, whatever the side length is. And look, it's y equals 4x is our constant. So y equals 4x is our equation for the relationship, and x, y, when x is 1 and 2 and 3, when x, we've started with 0, when x is 1, y is 4, when x is 2, y is 8, and so on. So I'm graphing up. When x is 3, 3 times 4 is 12. Okay? Here's something I'd really like you to see. This is important. When you are graphing y equals kx, we're going to go up 4 and over 1. 4 is our slope. And it starts at 0, 0. Every time we graph a direct variation, we start at 0, 0, and we go up 6 and over 1, up 6 and over 1. Our slope is 6, and we start at 0, 0. Please make sure you understand that, because that's going to be really helpful in the next, as you're working these problems. So our homework right now starts on page 339. We're doing numbers 10 through 27 and numbers 36 through 40. And please realize after 5, 6, you have a quiz. You're going to work the problems. You're going to correct the problems. You're going to take a quiz on 5, 1 through 5, 6, 6. That's a lousy 6, but you get what I'm saying. Please make sure you ask me any questions. Please stay up on your homework, and I will see you next time. Thank you much.